Good afternoon. Today, actually, I'm going to discuss the transistor. Okay, in the earlier class, we have discussed about semiconductor density of state. This density of state is very important for calculation of carrier concentration in electron conduction band as well as valency band. I'm not going to give the detail because you have to study again that part in next semester and onward also, and PG also. And basically today I'm going to focus on transistor. ECD sir have already teach you the diode. I'm not going to teach the diode part. I'm going to focus the semiconductor transistor part, which is transistor is nothing, just combination of three semiconductor, or you can say that combination of two diode. Okay. The internal mechanism of transistor is you can understand with the help of the mechanism of diode as well as semiconductor. Okay, today I am going to start the bipolar junction transistor. Bipolar transistor. Bipolar junction transistor, or simply we call the transistor. Okay, transistor used for amplification purpose. For example, suppose some signal is very amplitude is very low and it is not suppose in audio amplifier, in speaker also, if the signal is very low, then we have to use amplifier. So different purpose we can use transistor. So that's what application of transistor in different domain I will discuss later. First I have to understand what is the internal mechanism, what is the basic structure of the transistor. Okay, why it is called bipolar transistor? In semiconductor you have studied there is a two carrier, one is the electron, one is hole. Okay, in transistor, why it is called bipolar? Because current in transistor is contributed by both electron as well as hole. That is why it name nomenclature as a bipolar junction transistor. Bipolar, current is not to either hole or electron or both. Okay, there is two type of semiconductor transistor. One is a NPN transistor, one is PNP transistor. PNP, this is two type of transistor, bipolar junction transistor. One is NPN transistor, and another was a PNP transistor. So why N? Suppose this is a semiconductor, this is N type semiconductor, this is P type semiconductor, and this is N type semiconductor. If we combine three semiconductor, it will give NPN transistor. Okay, NPN. Clear? Okay, or you can say this is suppose diode. This is NP diode, PN diode. This is a diode. Okay, and another one is a PN diode. The two diode. If we combine it, then what happens? It will look like this. If we combine this two diode, then it will be look like this. PP is common, so we will write only P here, both side P. Okay, N, P, N. So what we can understand, you can say transistor is a combination of three semiconductor, or you can say that it is a combination of two back-to-back diode. Okay. Okay. This is NPN and PNP transistor. Why it is called NPN? Before going to that, we have already studied semiconductor. Depending on the carrier concentration, what type of semiconductor? Intrinsic semiconductor. In intrinsic semiconductor, number of electron is equal to number of hole. But in case of extrinsic semiconductor, there is a two type of semiconductor. Suppose this is a semiconductor. If there is a two carrier, hole and electron, and is represent the number of electron carrier. Okay, if the number of carrier in the semiconductor whole carrier is very large as compared to electron, then it is called P type semiconductor. Okay, and if number of electron in semiconductor is very large as compared to hole, then it is called N type semiconductor. Okay, from that concept we have to study NPN. NPN diode. This is a diode. Here N means the majority carrier electron and minority carrier hole. Here majority carrier hole, minority carrier electron. Okay. So what we can understand, Semiconductor transistor is a bipolar device. Why it is called bipolar? Because current is contributed by both electron as well as hole. That is why it is nomenclature as a bipolar junction transistor. Clear? Number 2, transistor is divided into two parts. One is NPN transistor, NPN transistor, and PNP transistor. We have to study both of these. By internal mechanism is almost similar. Okay. This is a one. This is a type of two type of transistor, NPN and PNP. So whatever it is, construction. So first I consider the NPN transistor. Whatever you can consider PNP transistor. Okay, no problem. This is P, this is N, this is P. Here, NPN. Here means this is majority electron, minority hole. Okay. Here P type, majority hole, minority electron. Here majority electron, minority hole. Okay. Now, and this side, this is the output side. This is known collector. Is represented by C. Okay. And middle portion is nomenclature base. It is represented by B. And this region is emitter. Okay. This is a representation of semiconductor. Transistor. Now you can see transistor is a three-terminal device. It is a bipolar junction transistor. Why? Because current is contributed by electron as well as hole. And this is output side is collector, always even fixed. And middle portion is a base. And this portion is called emitter. Okay. Now Now this base region is lightly drop. Okay. And emitter region, construction, physical dimension of the semiconductor transistor. Emitter region heavily drop. And this base region is the lightest, smallest as per dimension. Okay. And this is suppose 0.001. And this is this width is equal to suppose some 150 inch. Okay. This is a very small dimension, and this middle portion is base is very lightly doped. Emitter is heavily doped, is high dimension, and collector is also lightly doped. Clear? This is a basic. This is a basic construction. Now biasing. What do we mean by biasing? We have to whenever we study the diode, we always call the forward biasing, reverse biasing. What do we mean by biasing voltage? Okay, biasing voltage. Suppose you have studied in semiconductor. I am going to diode. In diode, so I am going to back. Okay, this is N, this is P. This is a diode. This is suppose forward bias. Now it is electron, majority electron. Forget about minority carrier. So if it is forward bias, then it must be negative. Why negative? I am telling you back. See, is a majority electron, minority hole. Okay, and then positive is the donor. Okay, this is negative and positive majority carrier electron. I will this forward bias. Now this voltage is called biasing voltage. Why it is called biasing voltage? Because biasing voltage is the voltage applied to the device. Okay, to be applied over the device to analyze the response of the device. Okay, this is called biasing voltage. I am again telling you, biasing voltage is the voltage to be applied on the device in order to study the behavior of the device. Okay, otherwise suppose consider me. So if you don't give me food or any item, any food item, then I will physically weak and I will not do anything. So in order to physically active me, you have to give proper food. Similarly, in electronic device, when you on the switch, suppose you consider laptop, you want to do something in your laptop. Okay, if you don't apply power supply to the laptop, you can't do anything. Similarly, in diode also, LED light is a diode. So diode, if you voltage to be applied over the diode in order to study the behavior of the device is known the biasing voltage. Now it is why it is called forward bias. This is negative. I will discuss this part later on. Later on I will discuss. First I will discuss the this part, transistor operation and representation. How we represent transistor? So suppose consider NPN transistor. See, clearly see, then you can understand. This is a base region, this is a P, NPN transistor, this is N, okay, this is now in transistor input circuit, this is, I am collecting here, I will apply voltage here, I will apply voltage here, okay. This circuit is called output circuit. Remember, this part is known as the output part, and this circuit is known as the input circuit. Represent IP, simply IP. Okay, and input circuit is always forward bias. So how can you remember? It is negative side, so you have to apply negative, and it will be positive. And smaller terminal represent negative, and higher terminal represent high vertical line represent positive. So it will be ground. Okay. Next, and back side is a reverse bias. This is input circuit is forward bias, remember, and output circuit is a reverse bias. So reverse bias, this is negative, and N means electron negative. So you have to in order to make it negative, then it will be positive, and it will be negative. Okay, this is how you have to represent. Now this part is known as a output side is known as a collector, okay, and middle portion is known as a base, and this portion is known as a emitter. Okay, clear? And this is why this dimension is very less, like base region is lessly dropped. Why lessly dropped? Because base region is lightly dropped means less number of electron, okay, less number of carrier. So in P region majority is electron, okay, minority is, this is very large in P region, and electron is very small, okay. And this is this now it is NPN configuration. I will tell you later why it is. Again I am telling you from the point of equation, okay. And this is a representation. This is NPN transistor. Now current, this is output current is represent collector current, okay. This is known base current, and this is known as a emitter current. Emitter region current is represent I suffix C, emitter current, and base current is represent suffix IB, and output current I suffix C. This is capital C, okay, capital C. For DC analysis, suffix is always capital, remember. For AC analysis, suffix is always used small letter. It is conventional representation, but not necessary. If you write small letter, it does not mean it is totally wrong. No, it's only to understand. It's a conventional representation. It is always called conventional representation. It is NPN DC. Now, how can you identify the direction of current? What is the direction of collector current? How can you represent? So I am giving you hints. So this circuit is simply written. This is a transistor. Transistor is represented like this. Always remember. And this is called base. This is transistor is always represented like this. You can represent like this also, but simply in books you can write this is OR. Okay, don't confuse. You can write this diagram also. You can write this diagram, whatever it is. And this is always represent base, and this is collector, this is emitter, and this is base. Okay. Now you can simply, this is NPN transistor, so it will be this is negative N, so it will be minus symbol plus, then it will ground. It will be ground. Why ground? I am telling you later. This is a reverse bias circuit, so it will be negative, it will be positive, it will be positive, it will be negative, it will be positive, negative. This is input circuit, this is output circuit. Okay, you can represent like this, you can represent like this. Okay, now my question is, what is the direction of this current is here? Output current is represented by, this is output current. Okay, input, this is emitter current, this is IB base current. Now what is the direction of current? How can you remember? So I am giving you short text, NPN, not to point in. Okay, point in, not to point in. NPN means not to point in. That means it will be out in case of emitter. So emitter will be out, move outward direction. Okay, if emitter is outward, then what is the direction of current? Then collector is inside, moving toward inside. Why? Kirchhoff law. Kirchhoff law junction point. Sorry, suppose this is a junction point. This is a junction point. This is suppose collector current IC, and this is suppose IB base current, and this is suppose IE. As per Kirchhoff law, what is the Kirchhoff law? To algebraic sum of current into the junction equal to the total current away from the junction, or you can say Kirchhoff law simply you can represent I summation I equal to 0. You can say, so this means IC plus IB equal to IE. Why? This is toward the junction and this is away from the junction according to Kirchhoff law. So IE means outward, means collector will be inward. Okay. This is representation. Suppose see again I'm removing. This is in case of NPN resistor. So once you see the direction, now you can see again I'm telling this is if I write like this is a transistor representation. Suppose I am giving a circuit. I'm not telling anything. I'm not telling anything. This is output circuit, this is input circuit, this is base, this is collector, this is emitter. Okay, and this is IE moving outward, this is moving inward, this is moving inward. So if I give this diagram, okay, if I give this diagram, I am not telling anything. You can see the direction of emitter current is outward direction. That means it is NPN resistor. Clear? This is how you have to represent. So this is I'm telling you only representation of transistor right now. This is the representation. Suppose I am writing here, and this is now again I am writing the P and P. Now I am writing changing the direction. Okay, what will be the direction? What is a PNP transistor? Now you see it is positive side, so it must be forward bias. Okay, then forward bias, positive to positive you have to connect. Why positive to positive you have to connect? I am telling you right now. Okay, after finishing this part. And it is forward bias, this is positive and this must be positive, then it will be forward bias. Okay, and this is must be reverse bias. This is positive, this must be negative, this must be positive. Okay, it is only change of that parameter will change the NPN resistor to PNP resistor. Okay, here PNP means pointing is only to remember pointing in. Only to remember I am giving this one. Pointing means emitter current will be inward direction. So if the emitter current is inward direction, then IB will be outward direction and collector will outward direction. IC will outward direction. Clear? So by looking at the circuit and direction of current direction, emitter current, collector current and IB current, we can identify whether it is P type or N type transistor. Okay, this is basic representation of semiconductor. And another also this is called, we will apply what? We will apply battery. or DC power supply. Here we will also apply DC power supply. Similarly, here we also have the positive voltage and battery 1.5 volt or 2 volt, whatever it is. Okay, I will discuss later. So this is a DC analysis. How? I have already told the suffix is capital, means we are using conventionally is capital letter represent the DC analysis. Why DC analysis? If you want to apply transistor any electronic device in AC application, before that, in order to establish proper operation of transistor, you have to apply DC first. Okay, so I am giving a simple example. Suppose you want to do a dance performance in some competition hall. Okay, before appearing in the competition hall in the dais, you have to prepare yourself at the home. Okay, you have to ensure your dance is proper at this home. Once your dance is proper in your home, you ensure it. After that, you go to the final stage. Similarly, in transistor also, if you want to apply AC analysis, because AC voltage, this household is a frequency 50 Hz, household 220 voltage, we have to apply on a AC device, any electronic device. So it may damage, it may burn the whole electronic device. So before that, we have to ensure the proper operating condition of any electronic device. DC voltage, thus electronic component will be safe. Okay, it will not burn. We have to ensure what is the voltage we have to apply, what is the maximum voltage to be applied in an electronic device in order to avoid the burning or destruction of the device, frequency of operation of the device. We find out that all the detailed information about the device we will find out with the help of DC analysis first, then we will apply AC application. Okay, this is only for DC analysis. This is representation of transistor. Now I am going for transistor operation. How we will operate a transistor? Transistor, how we will operate it? So since I have already told you, the operation of transistor is combination of two back-to-back diode. Okay, once you understand the diode mechanism, diode operation, then you can easily understand the transistor mechanism. Okay. So in case of it is not included here, but I am telling you what is the operation of diode, how we can understand. Okay, first of all, we try to understand. This is I am going back to the diode. This is N side, this is P side. Okay, this is N side. This is voltage we are applying. Voltage we are applying here. This is a diode, okay, not transistor. In order to understand, make you understand the basic mechanism of transistor, I want to going back to the diode. Okay, here N side means majority electron. These are the electron, maximum number of electron, and one hole, one or two hole. Okay, what you can see, so negative, this means electron. Okay, majority carrier. Because why it is majority carrier? Because N side, N represents number of electron. Majority carrier will be negative. Okay, plus means whole. Remember. Okay, and another carrier charge will be there. What will be there? Positive. You do not confuse this positive circle or negative circle. The positive circle does not mean a hole. Okay, do not confuse. And negative circle does not mean as an electron. It's an ion. Here is a N side. Is it positive or negative? Can you tell me? Positive or negative? Ion is also there. Negative ion or positive ion? How can you identify? One example I am giving you in order to confuse. Sodium chloride, NaCl. This negative means electron, positive means hole. Positive circle does not mean hole. Okay, don't confuse. And negative circle does not mean hole. These positive circle and negative circle means these are the ion. Okay, how can you use sodium chloride? You see the sodium chloride. Sodium 11 positive. It is represent positive ion. Okay, and chlorine atomic. This is atomic number 11. 2, 8, 1. 1 is represent positive side. Chlorine is 70. Atomic number 70. So it will be chlorine negative. Negative means we represent negative. So here means donor electron maximum. This is there will be donor. This positive maximum electron is a donor size will be there. This some donor size will be there like that. Okay. this positive some donor. This is ion. Okay. These are the ion. Similarly, in this negative, this is a majority electron hole. So maximum hole, minority electron, and hole. Now there will be also this positive means maximum number of positive hole. Okay, small minimum number of electron. Negative side, negative means this is number of electron. Okay, and there will be P. P means hole. It will accept the electron. Okay, so there will be what type of ion will be there? C, sodium chloride. Chlorine accept one electron from sodium. Chlorine atomic number 70. Okay, and it will accept electron, so it will become negative charge. One negative charge. So negative ion will be there. Some negative ion will be there. Okay, these are ion. Positive means I am telling you donor, and negative means acceptor. Okay, acceptor ion will be in P side because P is vacant side, so it will accept electron. If you confuse, then sodium chloride, remember. Chlorine accept one electron because chlorine has a vacant side. So, okay, so that it can accept one electron from sodium, so it will be negative. So negative ion will be in P side. P side has always a vacant side. Okay, and N side is always donor. Donate, it can donate the electron. For example, sodium can donate one electron to chlorine, so it will become positive ion. This is a donor. Okay, ion. This is positive circle means not hole. Okay, positive circle means it is a donor, and negative circle means hole. Negative circle means acceptor. Only negative circle means electron, positive means hole. Positive circle means donor, and negative circle means acceptor. Why acceptor in P side? Because P side is already has a vacant share. Okay, vacant share means it will accept. Suppose I borrow money 1000 rupees from you. Okay, that I can take it. Then I will be negative ion. You have given 1000 rupees to me. That means you are positive ion, positive circle. Okay, P can accept electron, so it will be and negative circle. Negative circle means acceptor. Okay, now it is in without biasing condition. Without biasing condition, that means we are not applying. Till now we are not applying the voltage on the device. This is the internal electronic structure representation of the diode without the application of external voltage. Okay. Now I am condition 1. Condition 1, forward biasing. Forward biasing. And biasing, I am telling you what is the biasing voltage. Biasing voltage means voltage to be applied on a device to analyze the behavior of the device or to analyze the response of the device. Okay. For example, if you want to operate your laptop, you have to connect the laptop with current or any battery source. Then you can operate the laptop, and then you can check the performance of laptop, whether it is working condition is good or not. How can you, if the laptop is off, how can you say no? You can't say anything. So you have to you have to connect the laptop with the current. So once you connect it, then you operate the laptop, and then you can verify or you can say anything about the electron. Similarly, the behavior or response of any electronic device you can only analyze after giving a voltage. That voltage is known as a biasing voltage. Clear? Now, why this forward bias? See, this is a maximum, this side maximum number, forget about ion, okay? Right now, forget about ion. Ion is immovable, be heavy, because you see, sodium chloride, if we see sodium positive, it will represent a positive circle, the donor. Chlorine accept one electron, so it will be chlorine negative, so acceptor. These ions are very, very heavy as compared to electron and hole. Okay, I will tell you later. Remember, ions are immovable. Immovable means it cannot move long distance because of heavy weight. Okay, now I am focusing on the mechanism. Now I have to apply these two conditions. One is without application of voltage. This is without application of voltage. This is a structure. And now I am going to apply forward bias. Why it is called forward bias? You see, this side is majority electron, okay, and minority hole. Then if I move, then this side is a positive. Positive means suppose you consider vacant share is there this side. Okay, now my aim is to transfer electron from this side to this side. So how can I transfer? If I take a positive voltage, then what happens? This is a positive. This is negative, all electron will like this, it will take like way, okay, stretching way, if it is positive. Okay, now I have to send the electron from this side to this side. Then what I have to apply? Negative voltage I have to apply. This is a negative side, negative and negative. This is already negative side. Why it is negative side? Because maximum number of electron is here. So this negative is repel negative charge toward this side, okay, and this is a positive side, positive, this is a maximum hole, positive hole is there, this will repel the whole this side. Finally, as a result, this electron move this side, hole is moving this side, clear? And this is why it is called forward bias. Now, after application of voltage, this is forward bias. Okay, suppose this is P side, this is N side, then it will be reversed accordingly. P side is connected to positive and negative side is connected to negative. That means this negative side will repel the electron, negative side toward this direction, and positive side repel the positive toward this direction. As a result, electron will move this side, the hole will move this side. Clear? And this is why it is called forward bias. Okay. Now, after connection of voltage, this is I'm simply writing this one, okay, this is N side, this is P side. Now I'm applying the voltage, this is negative, this is positive in case of diode. Okay, now after application of voltage, it will behave this part, okay. I'm for better understanding, I'm writing here. Okay, after application of this side, then what happened? This negative, there will be layer. Do not confuse. This is block diagram. And this N side, this is P side, is a donor. Negative ion will be there. Negative ion. This is a donor ion, okay, acceptor moving this side, because you see this is positive. This whole maximum hole, and 1 or 2 electron, and this positive and this maximum electron, 1 or 2 hole. Okay, after application of forward bias, this immovable ion come very close to a layer, because this negative acceptor will attract the positive donor, and this negative accept this one, they come closer and like form a layer. Okay, this is known as a depletion region. This region is known as a depletion region. Okay, clear? This is known as a depletion region, and it is positive and negative. It look like a parallel plate capacitor. parallel plate capacitor. You have already studied parallel plate capacitance epsilon A by D in free space. This is called depletion region, and form a capacitance is similar to the parallel plate capacitor. Clear? This is in case of diode. Okay. now this parallel plate, this look like a parallel plate capacitor, capacitance will create a voltage. Okay, that voltage opposed to the movement of electron. If we reduce the depletion region, that means more number of electron can jump from this side to this side. If we reduce the width, then more number of electron can jump from this side to this side. Suppose the depletion region is this width. Okay, and now few number of electron will moving from this side. Now in depletion region is gradually increases. Then what happens? Electron from this side cannot move this side. You will get a zero current. Okay, this is in case of forward bias. Forward bias means we aim to reduce the depletion region so that we can send maximum number of electron from N side to P side in order to get a output current. This is in case of diode. Okay, now if it is reverse bias. Now if I connect the reverse bias, if it is reverse bias, now it is reverse bias. Forward means reverse bias. What happened in reverse bias? Reverse bias, what happened? This is and this is P. Reverse bias, this is majority electron. So majority electron, minority hole, minority hole, maximum number of electron. Now reverse bias means this side is negative, I will connect positive, and this side is positive, maximum positive hole and 1 or 2 electron. Donor, this is a donor, this is electron, maximum positive, 1 or 2 this maximum hole, this is positive side. If I connect to the negative, then what happens? This negative attract the positive hole like this negative side move toward the, because of this is positive, the positive side, this is negative side, this will attract like this electron toward this direction, hole toward this direction. As a result in depletion region look like this. Depletion region, this is positive, negative. This is ion will form at the junction. This is called junction. Okay, this is junction, and this is ion cannot move beyond the junction. Remember, ion, because it normally they are called the immovable ion because they are heavy. Okay, if you confuse, then we compare the sodium chloride. Sodium is positive, is represent positive donor, and chlorine accept electron negative, it is represent chlorine circle. These are ion, these are heavy as compared to the electron. Okay, that is why they are known as a immovable ion. Now this depletion region C. Now depletion region, width of the depletion region is very high. Why? Because this electron, this is a negative, this is positive, they will attract stats like this, electron toward this direction, hole toward this direction. As a result, depletion region is increases, and due to increase of depletion region, the electron cannot jump from this side to this side. As a result, output current due to majority carrier is become zero. Clear? This is in case of diode. Okay, that is why we always never apply the diode in forward bias condition or reverse bias condition. And minority carrier means here minority carrier what? Small minority carrier. This side is small minority carrier electron, this side small minority carrier hole. So small minority carrier you will find in reverse direction. So forward current electron. Now what is the direction of current? Now how can you identify direction of current in diode? So electron moving this direction. Okay, hole moving this direction. Okay, hole moving this direction. So direction of current is opposite to the direction of electron. So electron moving this direction to this direction. So electron current will be like this. Oh, sorry. Electron current will be like this, and hole current will be opposite direction. Okay. Why this is direction of current? Because electron, this is negative, this is positive. Under forward bias condition, this electron will move this side, hole will move this side, and direction of current conventionally taken against the direction of electron. Here is the direction of current like this. Clear? Okay. Now in reverse bias condition, depletion width is very high. As a result, electron cannot jump from N side to P side. Okay. As a result, forward current becomes zero. Clear? Suppose I am giving an example. Suppose you want to jump. Suppose this is a canal. There is no road condition. Okay. This side the road is totally breakdown. The gap is in this much. You can jump. If I increase the gap like this, you cannot jump. That means you cannot come from this side to this side. So finally, what I am getting in my home, if suppose I am waiting for you, if the road is breakdown and braking portion is very high, you cannot jump. Finally, I am not getting in my room. Okay, and this similarly happen in diode also. And this is called the depletion region. And this is, don't confuse, negative cycle means acceptor and positive cycle means donor. They are ion, they are not going to contribute the current. Only contribute the current is positive and negative. Not positive cycle, not negative cycle. These are immovable line. Okay. Now this is the internal mechanism. So diode current, now focusing on the diode current. Reverse. Forward current. Forward bias, under forward bias condition. Forward bias condition, I am simply right. I am not going to give the internal mechanism. This is, suppose you can consider P or N also, no problem. This is, if it is N, means you have to understand this is a negative side because piezoelectric again electron. Then you have to, if it is forward bias, then it is, you have to connect negative. Small vertical line means negative. High vertical means may positive. Okay. And sometime in book it is written like this. Okay, more vertical, high voltage, no problem. Only better you simply write one or two line. No, we can understand. Small vertical is negative, high vertical is positive. Positive side is connected to P side. Then P, this positive will repel P hole, and this negative means repel electron this side, and as a result, electron move this side, hole move this side. Okay. But hole current is exists inside the semiconductor. Outside semiconductor, there is no question of hole current. Outside semiconductor, I am talking about here. Okay, if you measure the current here, so you will get a emitter current. I mean, suppose you put a emitter, you will measure the current. But that current is only because of electron, not because of hole. Clear? Okay. Then inside this portion, the hole current is exists inside this portion. Outside semiconductor, there is no concept of hole current. Okay. Now what is the forward? Now I am getting the output current. This is the output current. So output current, diode output current is simply represent D suffix for this is the diode output current. So it is represent IS. What is IS? So I have already told in reverse bias condition. In reverse bias condition means voltage is negative. Negative is connected to positive, positive to connected negative. Then it will be reverse bias. Reverse bias condition, depletion will be very high. As a result, majority electron or hole cannot move. As a result, majority current will be zero. Okay, and minority current will be there. That current is known as a reverse saturation current, is represented by IS. Clear? And I am removing this diagram. I am back to the mathematical equation. This equation, this is forward current. This is forward current. Okay. E V by KT minus 1. KT. Okay. Minus 1. This is the equation. This equation is known as a Shockley equation. Shockley equation. Remember, this equation is known as a Shockley equation. This equation is not a linear equation. Clear? IS is the reverse saturation current, E is the size of electron, K is the Boltzmann constant, T is the temperature, and P is the voltage you have applied. That is known as the biasing voltage. That's what I am telling you. Suppose Suppose this is a P, this is N, this is P, this is connected negative, this is connected positive, this is V, this V is this one. Okay, this is known as a biasing voltage. Clear? And this equation is the Shockley equation. This is the forward bias condition. Okay, this is a forward current. Okay, now you see what I can understand. This is a forward current. In reverse bias condition, now I'm reverse bias condition. Now I'm removing this part. Okay, reverse bias condition. This is only in case of diode. Don't confuse that I'm teaching this part is a transistor. I'm going to teach you transistor part, internal operation of transistor. Before going to that start that part, I want to give you basic idea how diode is working. Once you understand the diode, same mechanism happen in transistor. Then I am not going to give you detail about the internal mechanism of transistor. That's why I am giving, because transistor is a combination of two back-to-back diode. Once you understand one transistor, a diode, then you can easily understand. Okay. So in case of reverse bias condition, suppose this is a N, this is P. Now reverse bias, this is a negative side, this is positive side. So if I connected negative to positive, positive to negative, as a result it will stretch. Okay, this voltage is V, and it is represented as a negative voltage. Okay, now we see it. Now equation diode current equal to Is e to the power minus, why I am writing minus, you see E by minus V, negative voltage. This is a negative voltage because negative is connected to positive, positive to connected, that is represent negative voltage, by kT minus 1. Clear? This is the reverse bias diode current. Okay, then Is e to the power minus EV by kT minus 1. Clear? Everything what I am going to tell you, no need to remember anything. Everything you just want to understand from the mathematical equation. Okay, now what is the meaning of this equation? You can express Is is constant, forget about that. This is a negative part, I can represent 1 by e to the power EV by kT. This is E means exponentially, E means surge of electron, don't confuse. Minus 1, is it okay? Minus means 1 by x. See, x to the power minus 2 means what? 1 by x square, right? Similarly, e to the power EV by kT means 1 by e to the power. Okay, I am removing this part. Then diode current will be Is. If I express e to the power x, you have already studied what is the value of Ex. E to the power x means what? 1 plus x factorial 1 plus x square by factorial 2 plus like that. Okay. Similarly, if I expand this part, 1 plus EV by this is x plus 1 by factorial 2 EV by kT square minus 1. So now this is a V, reverse voltage. If reverse voltage is very high, then what happens? E to the power x is very high because E by kT is constant. Forget about that. If V is very high, this denominator part going to be very high. So that means 1 by very high number. Suppose this is 1 by very high number. Suppose 2 like. Then it is tends to 0. Is it okay? So these terms, this Is is there, this term tends to almost 0, minus 1. So it will be minus S. What I am getting in reverse bias condition. So forward current equal to the reverse saturation current. This reverse saturation current is only contributed by minority carrier in diode or in minority carrier or in semiconductor. Okay. So this is in case of I'm forward bias. I'm writing again forward bias Bayes equation, ID equal to Is e to the power EV by KT minus 1. This equation is known Shockley equation. Okay. Reverse bias ID equal to minus Is. Clear? This is a reverse bias equation. And this equation is derived from here, mathematical equation. Now characteristic of diode. You have already studied, SOD sir already teach you, but in order to make you understand semiconductor or transistor part, I am telling you. So now how can you confirm in this is direction voltage or current? So look at this equation. EV by, do not confuse. Now you have to study. This is the diode equation. Diode characteristic is, what are the variable? Is is constant, clear. E is constant, K is constant, T is constant, 1 is constant, only variable V, and left hand side variable V, I. So I have to plot the diode characteristic, current versus voltage. Current this axis, voltage this axis. Is it okay? No. Y equal to mx plus c. So x is what? Independent variable. Y is dependent on x. So similarly, ID is independent variable, dependent variable. So ID will be this direction, okay? And voltage is, once you put the value of voltage, then you will get current. If we do not apply voltage, you will get zero current. So that means what? Diode current is a dependent variable, and voltage is independent variable. Voltage you have to apply. Okay, voltage will be this direction. Diode voltage. So characteristic would look like this. And this will be look like this. Okay, and this region is called knee voltage. Knee voltage is what? I have already told you. Depletion is on positive charge, positive donor ion one side and negative acceptor in other side. As a result, it will behave as a parallel plate capacitor. Voltage will be developed in the depletion region. That voltage is this one. Okay. Suppose this voltage will oppose the movement of electron. Okay, I am telling you again. This equation you have to clear now, right now. This is the depletion region. Positive, negative, positive, donor, negative. This is ion, okay? Don't confuse this electron. This is 5 volt. This is negative, this is positive. Voltage supply. This is equal to 5 volt apply. Okay, this is equal to 0.5 volt generator. This will generate 0.5 volt, suppose. Then you have to apply. Suppose you want to get a current, output current ID. If you want to get output current at the output terminal, suppose I am not doing it, I know this voltage. You have to apply beyond 0.5 voltage. Up to 0.5 voltage, it will nullify. It will oppose to the movement of current. Okay. Suppose I am giving another example so that you can understand. Suppose you have to give me 500 rupees. Suppose I want to take money from you, 500 rupees. But you have to give me 50 rupees. You have borrowed me from many months before 50 rupees. Then what I will deduct? 500 minus 45. Similarly here, 0.5 voltage. If you want to get the output current at the output terminal, you have to apply voltage beyond 5 volt. Beyond 5 volt means 0.5 volt. Up to 0.5 volt, the current is 0. After that, it will gradually increase. And this is a forward current. Is represented by ID equal to Is e to the power EV by KT minus 1. And this is the reverse current. This is a ID equal to minus Is. And this reason is, sir has already discussed, this is the general reason. I will not discuss that part because I am going to transistor part. Okay. This is in case of diode. Okay. Now I am going back to the transistor. So now Now I'm not going to the next class. I will start transistor. I will move very quickly, because see why I'm not going to move. Again telling, in transistor there is a N, P, N. Now this side majority electron, donor ion will be there, minority hole. Okay, this side majority hole, minimum number of hole, and this number of maximum number of electron. So if I connect this, an input circuit is always start, this part is known as the input circuit, and this is negative. I have to connect forward bias, so I have to apply negative terminal. It will be positive. Is it okay? Positive, positive. Okay, negative, negative, forward bias. And the output circuit is reverse bias. This is negative. I will connect to what? Negative. Reverse bias, I have to make it reverse bias. Is it okay? It's very simple. Now internal mechanism is similar. Diode, you consider diode, how it will move. This majority electron move this side. Okay, and similarly this you can consider PN diode. Okay, this is the output circuit, input circuit. Okay, clear? This is the, do not confuse, this is known as the emitter. This middle portion is base, and this output portion is collector. Transistor is, I am again telling, transistor is a T-terminal device, and bipolar junction. Why it is called bipolar? Because current in the transistor is contributed by electron as well as hole. That is why it is nomenclature as a bipolar junction transistor. Why it is called junction? There is a one junction, there is a two junction. Okay, and there is a T parameter. Output current is always represented by collector current. Input current in this circuit, okay, input current either may be base current or not a emitter current. This is emitter current, okay, and then base current, okay, and direction, this is NPN transistor. NPN means not to point in, so emitter current will be outside direction. Once it is outside direction, as per Kirchhoff law, that it will be base current will be inward direction. Okay, clear? And then representation is very easy. Transistor is simply represented like this. You can write like this, or you can write like this. This is base, this is collector, emitter. Emitter and collector look like similar, but output side is always collector. Remember, input side. This is the input circuit. This is if it is emitter current is represented by outward direction, then you have to understand this is NPN transistor. Okay, then you have to connect negative to forward bias. This is a negative terminal, which is this direction. This is the input circuit, and this must be reversed. This is NPN negative side, so you have to connect positive, so it will be positive. This is output circuit. Okay, output current is IC. So I will discuss in the next class how transistor mechanism and calculation gain, how much gain is obtained in transistor, current gain in okay, different combination of transistor. First I will study different combination of combination of transistor. There is a T combination of transistor, and how the behavior of transistor in input circuit. Input circuit means this portion, this side. What is the behavior of transistor in output side? This part, output circuit. So once we finish that part, we can directly move to the current gain parameter, alpha, beta, okay, and different combination of transistor. And after that I will move application of transistor for various application, push amplifier, oscillator, different purpose, how a transistor can be used. Okay, and at the last I want to tell you one thing. So if I ask you what is a diode, is a linear device or non-linear, do not confuse. Diode is a linear device or non-linear device. So device, whether it is a linearity and non-linearity, depend on Ohm's law. Ohm's law, you have studied Ohm's law. Ohm's law, V equal to IR. Okay, or you can say I equal to 1 by RV. That means I proportional to V. This is a linear resistance. Okay, any device, if it is follow that equation, that is known as a linear device. But in case of diode, because we have already studied Is e to the power EV by kT minus 1, this is a non-linear equation. Okay, and that is why diode is a non-linear device, remember. Or you can analyze the, because we have already characteristic of diode is look like this, this is a VD, biasing voltage, this is forward bias, this is a reverse bias, okay, and this is a diode current positive, this is a negative diode current. It is non-linear characteristic, curve is not linear, so diode is a non-linear device. So remember, this is very important question. Okay, so next class I will go to give you the detail about transistor and different combination of transistor and mechanism of transistor. After 1 or 2 class I will directly move to the application of transistor. Okay, thank you.